Hi. In this video, I'm going to go through the process that I used for developing the DHART extension for Omniverse Create. It should generally be useful for people in scientific computing or anyone that wants to incorporate a Python package into the Omniverse system, especially for something like a visualization of scientific data. There's a couple things that I implemented and usually do when I'm developing an extension. First thing that we'll do is make a new extension from the project template. I'll just put it in my documents folder, call it DHART-OV. I'll select this as my folder. I'll call the project name DHART-OV again. And the extension ID, I don't want to use Dart because that's the name of the pip installable package that I'm going to use. So I'll call this DHART _ extension. When I generate that, this new window opens. Ideally, we want to set this up so that VS Code is going to open instead, and then we can connect to it. Since this is a new install, I'll go to VS Code now. Or you could enter from this path code.command. And this will launch VS Code in that folder for you. I'll say yes that I trust this. And under the launch settings, we should have a local host and a port to connect to. So now that we have our window available, the next extension I'm going to add is going to be called the VS Code Kit Debugger. And now that this code is enabled, we'll just check that it works by opening up our file, going to our extension.py, double click to lock it, and I'll put a breakpoint on one of these lines. Because it's a new install, I need to install the Python module. Okay, and now that Python is installed, we won't use lint. We can break here. Next, I'll go over to Run and Debug, and I will click on the Run and Debug. We should see that VS Code Debugger is now attached. And that means if we do something like break on the clicked, and we press click, we will see that we have broken here and our local global variables are there. Okay, so that's the general setup for debugging our kit extension. Next we're going to get into how to set up our project so that it is a little bit more comfortable for us to use. All of these files have been generated automatically. The only thing that's different is our project name. So we do want to change a couple things, like my extension. I'm going to call Dart interface. Our Dart extension is called Dart extension. On startup, instead of my extension, I'll just say Dart is starting up. And here I'll say Dart is shutting down. The next thing that I like to do is move our window widget. So instead of being in the startup function, I'll say def show window. And I'll put that same exact code in there. And in our startup, we will call self.showWindow to make sure that we're still calling this window. Every time you save, it hot reloads, meaning that if we were to change some letter, we should be able to see that update happening. If you don't see that update happening, it could be because there's an error in the loading. So for example, here it disappeared, and that's because in the console, we'll notice there was some error. So I'll fix that, I'll save it again, and it shows up. The main thing that we need to do for using a Python package, especially from the pip installer is go to config and extension.toml. In this location, we'll notice that there is an ability to say python.pip API use online index equals true, requirements equals DHART, and DHART is the name of our package. So if we were to say pip install DHART, this is what we are doing here by adding this requirement. So let's save that. After you set up the extension.toml file for DHART, it'll either immediately load, or on the next reload, you'll have to go to extensions, search for your extension, unload and reload. And when it is reloading, it will go to pip install DHART. It might freeze the UI for a little bit because it's running the whole pip installer, and currently there isn't a way to see what that progress is. But after that first run, you can see that it unloads and loads very quickly. So now I'll copy over the different functions that I was using to make my extension and try to explain them piece by piece. So the first part was that I created an initialization function, self.initialize. And in this initialization, it took a couple of components. One was that we have this call to a core file. So in DHART, I'll make a core.py file. And then in the extension, I will use a local import. So from .import core. In core, I made a class for my functions, and that was called DHART interface. And there was a couple of imports that I need for DHART, so we'll just import them now to make sure that it's loading correctly. And I also made an init function that had the two components that I need to pass to DHART. One is a BVH and one is a starting position. So when I save this, and I will save this extension. So now our initialization is set up. We're getting this class instance. The next thing that I wanted to do was subscribe to an event. So I wanted to know, when did I select some object? And when I change my selection, I want to have that selection in a container so that I could use it to assign as a mesh or a starting point. I found this really great blog from Michael Wagner that talked about how to subscribe to events. So in the initialization function, I just copied over his work. In his example, he showed how to get the stage, get a selection from the stage, and subscribe to the stage change events. Along with that came a requirement for another function that was called onStageEvent. That was this one. And then this one requires an onSelectionChanged function. And so I'm going to copy over that whole function that I had modified for my own purposes. So in this part of the function, we get the selected prims that are on the paths. We create an empty list that's going to store all of the prims. We check to make sure that we do have something selected and there is a valid stage. And then we iterate through all of the selections. At each selection, we get the primitive that is being selected and we append it to our path. This primSelections.append then is checked to see that it's not empty, that there is something valid there. And if there is, we set a class variable called ActiveSelection to our DHART interface. So in DHART interface, we're going to have this ActiveSelection equals none. This way, we kind of have a global variable that's tracking what is the currently active selection, because it updates anytime we've changed our selection. So that becomes our current prims, and we just print out that the prim selection has worked. In order to just check whether we are selecting prims, I'll go over to our stage, I'll click on something and it says set DI to USD, and we could create an object, and when we select it, it says it's set to cone. We set default light, we set to default light. If we click two things, then we're creating a list of two things. So this is all working well. The next thing was creating a couple of buttons that we actually want to use. So I replaced the default buttons with my own set of functions and buttons that I need. Importantly, we need to set a starting position, we need to set a mesh for a BVH, and we need to generate a graph. Because these all come with a Lambda function that we need to call, they're all part of the self.dart interface, which means that we need to implement these functions. So the first one we're going to implement is set as start. So down here, I will click set as start. Set as start requires us to import Omni. So I'll say import Omni. We can also use NumPy, which is a built-in. It comes with so this code, what it should do, and we can drag and drop these two functions. These are the only two files that we're using. So set start position here is going to call set as start, and in set as start, what we're going to do is check that there is an active selection, and if there is, we're just going to get the first object that we selected. We're going to set that to our start prim. We're going to say that our starting location is the start prim. Then we're going to say that our starting point is omni.usd.utils.getWorld transform matrix. We pass it a primitive and we extract the translation. So initially what I was able to find through searching for the docs was this getWorldTransform function. And it actually didn't have this extract translation on it. So this just gives the world matrix. And what we'll find is if I put a breakpoint here, I can come back and I can create a object. I can select the object, it says it's selected, and I'll click set to start position, and it says starting point is, and it gives us this starting point. If we come and reattach, now when we run the code, we will break, and when we break here on self.startPoint, you can step over, and when you step over, you'll be able to see that self start point is a matrix 4D. You could look up the docs, but one of the easier ways to do this is actually open up function variables, and in the function variables it tells you what options there are, and that's where I found the extract translation. So I just kind of assumed this one's going to work because it is the translation that I want. So if we put that back there and continue, now when we select an object in the start position, we get 0, 0, 0. We can move it over and we can set the start position again, and we see that the value has updated. So this seems to be working pretty well. The next function was set as BVH. So the set as BVH function does a similar thing. It checks for the active selection. For now, it's just taking the first selection, and then we get the primitive type. Once we have the primitive type, we check if it's a mesh, and if it is a mesh, we're going to run this function convert to mesh. We don't want to pass start an invalid mesh, so this helps with that. This is our convert to mesh function. We need to import the USD geom, so we'll say import say from, this is from Pixar's library, from PXR, import USD geom. So now that's imported. We can get the mesh from USD geom by passing it the prim, and I know from Dart that we need to get the face indices and we need the vertex values. The first step is getting the mesh itself, and that can be done by USD geom.mesh and passing it the primitive. If I go to my repo, I know from Dart that I need to be able to pass it. So on Dart, I know that I need to pass it a mesh info. Mesh info is going to take a vertice list and indices or pointer list. So vertices are here and the triangles are here. So if we come back here, what I was able to do again was breakpoint, and when I click on a mesh and then set as BVH, I had this variable m. If I open up m and I look at the function variables, I can see all the functions available, and I was able to find some get functions. These gets include get face vertex indices adder and get points adder. Those two were what I used to get the triangles and the vertices. So if I step over, tries is now a list of triangles, and verts is a list of vertice points. The next step is to convert them to NumPy arrays. So that was pretty simple. I just wrap them in np.array, and you get tries, and you get try list, which becomes an int32 array, and you get a vert list, and vert list is a flattened list after we flatten it. Next, we pass the mesh info object, and we're going to get an exception here because DHART was expecting a proper mesh info, and this one did not count. So I'll delete this. I'll make a new mesh of a cube. I'll set this as the BVH, and we can see it passes without a problem. It says self.bvh equals Dart ray tracer, and print bvh is self.bvh. So now we have this whole process. We've converted to a mesh. We've gotten the triangles and vertices out. We passed them to our Python program, which actually has a C DLL that it's calling to. So we went all the way from the USD format into our own custom C function through a Python package. The final step is the graph generator itself. So here there's this generate graph function we call generate graph. This is the generate graph function. The first thing that we're going to do is check that we have a BVH. So if there is no BVH, we're going to return because we can't run our algorithm without a BVH. We call this function scene setup. The scene setup simply gets the stage. So it's just an initialization thing that we are working on. We define some spacing and nodes, and this whole part is part of the original code base. So if I went to my documentation and I said generating a graph, generate a graph, we can just copy pretty much everything from here. You can see the imports are the same, and the only difference was instead of loading an OBJ from a file and generating the BVH from that, we're loading the mesh data directly from the USD and passing it the same way that we would if we were running this in a Python interactive terminal. So now that we have these settings, we can save this, and we have another function down here that is create points. There are a lot of ways to try to create points. I found that following some online examples where they create physical points like a sphere is a really, really slow way of doing it. So with a couple modifications over the day after that I worked on this, I was able to, with the help of a lot of people on Discord, get color displays on these primitives. So we define the USD_geom.points, and we define the stage that we want the points to be and the path of the primitive. We create a points attribute, and that is being passed by nodes. Nodes was a returned value from our graph. We said get nodes, and it's a structured NumPy array, so we got X, Y, and Z values out of it. We print how many are going to be there. We convert it to a list and pass it into our create points function. This creates the size of the point, so we can change this value. It's a floating point value. And this creates a color. Currently, this only works for a single value, so we have an USD_geom.tokens.constant, and this will set that constant value. So now that we saved our scene, we are able to create a BVH, we're running our graph generator, and we are able to print points. So now I will come over to our stage. I'll go to content. I'm going to look for DHART, which I downloaded on my own. So I went to the DHART repo, which is available here. I went to source, Python, DHART, example models, and then I have a couple example models, and I picked this no ngon model, which works best for Omniverse. So I have an OBJ here and I can just drag it in. I'll set this to the 0 position and make sure there's a 0 rotation. So now that we have this model in, I'm going to create a simple sphere just as a location. And if you press F, you can zoom into that sphere. I'll move it over here and then slightly up. So this will become the start point of my graph generation. I'll set the scale to 0.1 to make it a little bit easier to move around and recognize. Okay. Importantly, we want to select the mesh, not the X form. So we're going to open this up, select the mesh, set the mesh for the BVH, select the sphere, set the start position, and click Generate Graph. You can see it's pretty quick. It generates our graph, gives us a point, tells us that we have 25,000 nodes, and is visualized pretty quickly. So with those settings, we get this value. We can come back and then hot reload our script. So instead of limiting to 25,000 nodes, we can make it 250,000 nodes. I'll save that. And I'll do the same thing. Select my mesh, set for BVH, select the sphere, set as the start position, and then generate the graph. See, it takes a little bit longer. Now it generates 91,000 nodes. And that seems to be the limit of these settings. So we get this type of file. If we come back, we can change the spacing attribute. So this is the height that it's going to work at. We can change this to larger up steps. We can change this to smaller spacing, and we can change this to 500,000 nodes. So I'll save this. We'll come back here, select my sphere, set it as the start position, select the mesh, and then generate the graph again. This time it takes a couple more seconds and it's at 500,000 nodes, and we start getting a much more robust grid spacing, and we can actually start seeing our navigation graph is becoming much like a full navigation with even every step being recognized. So I hope in summary that this helps people implement their own Omniverse extension and helps with recognizing that you can just utilize and leverage a ton of Python projects that are already on pip that you have written, that other people have written, and you can use Omniverse just as a really simple way to visualize your scripts. So as a reminder, this create geom points simply took in a list. We got a stage. We were able to set a list of points with a size and a color. And that was all it took to do 3D navigation. In comparison with the Python docs of DHART, if we look at the generating a graph, there's a visualization tab. That visualization tab shows here's how to plot with matplotlib. About the same amount of code that it took for this, you can visualize in 3D. So that's it for now. I hope this was helpful.